Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have a way to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. Experience the fun. Test your rockets right now at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have a way to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. Experience the fun. Test your rockets right now at RockSim.com. And we're live! Hello, friends. I'm back. I was gone for the last 2 episodes, but I am back in the house, ready to talk about rockets. Yeah, I missed you guys. I was thinking about you, but I had Michelle covering for me, and I'm sure she did a great job. This is RockSim Live. This is where we talk about RockSim software and how to use it and how to get the most out of it. Today is December 9, 2022. Let me bring up my desktops here so I can show you what's going on. Let me bring up a web browser. We've got a lot of people that have sent in some questions. So I want to try to answer those, but I'm going to, if you have a question, put it in the chat, and I got the chat running over here on a second monitor. If you have questions on how to use RockSim, go ahead and ask it, and I will try to answer. But I did get a few questions this past week, and I want to answer those. So if you are here looking for your questions to be answered. There are some questions from Australia, so I'm sure they're not watching live, so they want to watch on replay, and I want to show you where you'll find those. So if you go to the ApogeeRockets.com webpage, it's ApogeeRockets.com, and then go to this image right here where it says RockSim Live Training and click on that, and that will get you to our archives. And so this is where it will be archived, and if you come here, this shows you what topics we talked about. I was thinking, how are you going to get to the archive when you don't know where the RockSim Live is? But I know you can figure out how to get to YouTube, so you probably find it. But you're particularly interested in your topic, and those will be listed here. And we'll get these posted on our website, usually about Tuesday of the following week. So this is what Michelle talked about last week. She was building the SpaceX Starship in RockSim. Holy cow, I didn't know that she was going to do that. And can you do grid fins in RockSim? Uploading designs to the launch visualizer. Launch visualizer, cool launch locations, graphics in RockSim. Adding custom parts to the database, how the finish of a part is calculated, and then printing parts templates from RockSim. So those are the ones that she talked about last week. And I'm going to talk about some other ones here. So my first question is from Pete Lamb. He built a rocket like this, and you can't tell, but it's got ring fins on it, not tube fins, not ring fins. You can see it. He sent a really good image right here. So this is what the rocket looks like. And what his question was, he actually slit the tube. Oops, right there. Let me get this one up. So here's his rocket. I'm trying to make it bigger so you can see. So he's got a tube fin here and a tube fin here, but you can see they intersect with the tube in the middle. And he actually, instead of cutting the tube and just gluing it on, these actually go through the wall, so they're attached to the engine mount inside the rocket. And he probably had to split this tube so that he could slide it over the rings of the fins to make the ringtail. So his question is, how do you do this in RockSim so you have through the wall fins on tube fins? And so he sent me his design, and this is what it looks like. Terry Wheelock says, can you design a grid fin? Terry, I think Michelle answered that one last week. And the answer, Terry, is unfortunately no. RockSim doesn't do grid fins because it's looking for a fin to be a flat plane. So here is a fin. We have to model the aerodynamics of the fin in RockSim, and I can't do grid fins. I can do tube fins, ringtails, and flat plates like you just saw there. This one is a tube fin. So if I look at it from the back of the rocket, let's see what it looks like in his design. So he's got the tube fins. I keep calling them ringtails, but they're tube fins. A ringtail goes all the way around, like a stovepipe. This is a tube fin, and it's just connected to the side. And if I look at it in 3D, you can see what it looks like. So how do you model a through-the-wall tube fin in RockSim? So that's a very good question. And you got to do a little trick. And the trick is to use a special component on the rocket called a pod. And this is the pod button right there where it says pod. So first, let me find his tube fins. And I just want to get, he's making them on a G10 fiberglass. He's got 2 of them, and their diameter of 4.6 and 4.51. Okay. What I'm going to do is I'm going to copy these to the clipboard. But first, I'm going to use that special component called a pod. A pod is a placeholder. So it's just a collection of parts. Like this right here is a collection of parts, and we call it a sustainer. But we're gonna add another collection of parts, and we're gonna call it a pod. So when you first add it to the rocket, you won't see anything. So where do I add it to the rocket? And I have a number of choices. I've got 2 body tubes. I got this lower one here, and I got this upper one right here. I could also add it to the nose cone, but I think it makes most sense, since these are going to be fins attached to them, to add it to the back. So I'm going to select the body tube in the parts tree, and then you see the pod button is activated. And I'm just going to click on it, and it's going to add the pod. And if you look very closely, this is the location of the collection of parts. Now for the sustainer, its location is right here. But for the pod, we wanted to give you an indication where that's going to be attached. So I put it right here. Now this location can be moved. You can see here I have a location, and I could slide it back to the back of the rocket. And I think I'll slide it back. I want to kind of position it where this other fin is located. So I'm going to slide it back just a little bit. Oop, too far. I'm going to have to type in a number. So let's type in 2.7 or 25.7. Oops, too far. 25.2. Nope, 2 is too small. 2.9. Nope. 3.5. Nope. How about 5? Nope, 5 is too big. How about 4.5? Okay, so that's good. So that's going to be my location where all the parts, when I start attaching them, are going to be right there. And we'll call this pod, we're going to rename it. We'll call it the tube fin pod. And it's got a couple of check boxes here. This pod can be ejected during simulation. So it's kind of like a typical pod that most people think of is like a strap-on booster pod, which is on the side of the rocket, and then they can fall off. And if it can fall off, we can eject it. So we don't want to eject it. Nor do we want to mark it as this pod is ejected. If you eject it early, then it doesn't show up as all the mass of the parts. So for right now, we're going to come back to this in a second. Okay, so there is the pod, and it's attached to the rocket, and you can't see anything because there's no parts attached to it now. So now I'm going to take these tube fins right here, and I'm going to do a copy of that, and then I'm going to paste it onto the pod. So I'm going to highlight the pod. So to copy, what I did was I used my mouse, and I did a right click on it, and it brings up this little menu right here, and you can do copy. You can also go up to the the edit menu and do a copy there. And then for pasting, I need to paste it onto the pod. So now I'm going to start adding parts to it. And so I'm going to paste it here. So again, I can do edit, paste, or I can do a right click on the pod and choose paste from there. So I'll just do paste. And you can see it added the tube fins. And there is my tube. And it's attached right now. Let me take a look at it from the rear view. I got some weird stuff. Oh, that's a mass object right in there. with everything colored blue, it's really hard to see what's going on. So I'm going to take these tube fins and I'm going to edit them. And the first thing I'm going to do is going to change the color so I can tell it apart. So I'm going to make these red. So that's the 3D color right here, and this one right here will be the 2D color. Okay, so now I can see my fin, and if I look at it from the back view, you can see there's two tube fins that are added to the pod. Now my pod location, if you're kind of wondering where it starts, where the front end is, I'm trying to spin this around without giving you vertigo here. It's right here where these two meet. That's the location where I selected to put the pod. So it's not on the back side of the rocket, it's right there at that point. So now I've got two of these tube fins attached to the pod. And why is there two of them? Because when I copied the blue ones, there was two of them on that set of fins. So on this tube fin, I'm going to drop it down to just one tube fin. I'm going to hit tab, so I changed the tube count to 1, hit tab, and it should go away. One of them should go away. Come on. My computer's running a little slow right now. Come on, I just want one. Let me click OK and see if it goes away. There it is. Finally went away. Okay. So now if I spin it around, you can see it's still attached right there. But now there's just one of them. So now I'm going to get rid of these blue ones because I don't need them anymore. So these are these other tube fins. And I'm just going to do a right click and then delete or cut. Either of them is going to get rid of it. And it's going to ask me, am I sure? And I say yes. So those will go away. Okay, so now we're getting close to what this looks like. But now we have to move the position of that. So if I look at it from the base view, I want to take this edge right here, and instead of being right here, I want to put it right there because we want it like coming around this way. So how do we do that? Well, I mentioned before that we're going to adjust the pod. And now is the time to do it. So I'm going to edit the pod location by double clicking on it. And you'll see that there's a radial position tab right up here. Let me go to a base view. Okay, so that's where it's attached. So we're actually going to move the pod off of the rocket because we want to slide it this way. So I'm going to go to the radial position tab, and you'll see that there's a radial distance and a radial angle. And by default, both of these are checked. And I want you to uncheck them. And when you uncheck them, then you can start adjusting these positions. So I'm going to take this, and you can see I'm sliding it up. I need to zoom out a little bit here so we can see it a little bit better. So I want to move it so that that edge right there just kisses that because he attached it to his motor mount. Okay, so now it's really jumpy. So we're gonna actually that's really good. 3.125 inches. It's just kissing it. Okay, so if I look at it in 3D, there it is on the side of the rocket, and it does go through the walls. That's really good. And now he's got two tubes. So basically what I want to do is just copy that pod. I'm going to click OK here because I like it. Go back to my main screen. Oops, where'd my RockSim go? My RockSim just crashed. Oh, that stinks because I just lost everything I just did. Let me see if I can get rid of everything else that's going on here. Free up some memory because it's running really slow. What we've discovered that it's actually OBS, which is the software that I use to run the video for this podcast. It sucks up a lot of memory, and I can't have too many things running at the same time. Oh, let's see if I can do that really quick. So basically, I had one on there, and then what I just do is to duplicate it and put it into a new position. So let me open his file again. Okay, so I'm going to do it a little bit faster this time around. So my design components, I'm going to copy the tube fins, copy. I'm going to add a pod to this body tube, uncheck this, and we're going to call it the strap-on booster pod. No, not the strap, the tube fin pod. And I think, I can't remember, we had it at 25.45. Yep, right there. Click OK. So now we added that. We're going to paste that tube fin on there. I'm going to go back to these other tube fins, get rid of them. Delete them, yes. Okay, so here's these, and we're going to edit these. Change the color to red so we can see it. Click OK. What else did we change in here? I think that was, oh, we changed it from a 2 to a 1. And hit OK. So now we have the pod. Then we went back and we adjusted the radial position. So let's look at it from the back. And we go to the radial tab, uncheck these, and I think it was, what was it? 3.125. Click OK. I'm going to save this. So I'm going to do a file, save as, because this is where I got to before. See, it only took me a few minutes to do this. And so, you know, I know what I'm doing, but it won't take you long if you're doing it from scratch. I'm going to throw this onto desktop. Through the wall. Click Save. Okay, so now I'm going to take this pod and duplicate it and put it on the other end, on the other opposite side of the rocket. So copy that pod, then come up here to the body tube. So again, I have to select the body tube to add a pod, but I'm just going to paste it since I already copied it. And now you see that there's 2 of them. So this is the second one. So I'm going to edit the second one. And we'll call this the starboard side. And the radial position, all we need to change is to put a negative sign in here, I think. Or maybe it's a radial angle of 180 degrees. Yep, that's what it was. 180 degrees. So now we have 2 of them, and they go through the wall. Let's click OK, and we can see that here. Let's look at it in 3D. And there we go. Just like what he had in his photograph. Now, the question you might have is, what difference does this make to the rocket? And for that, what I'm going to do is I'm going to open up another version of RockSim just to do an apples to apples comparison. I want to open up his old design and the new design, and we'll compare them. So I opened up RockSim Pro, but RockSim Pro and RockSim are, as far as designing the rockets, they're identical. Almost. There's like one little small difference. But as far as calculating the stability, which is what I want to show right here, they're identical. So I'm going to go back to his design, which was in my email, and I'm going to open this one up. And I want to do an apples to apples comparison. So what I'm looking for is the center of gravity. Oops, and you can't see it because it's under my face. Trying to throw it on the screen here. Okay, so this is the original design, and let's look at it in the base view. So you can see that that's the original one. But when we look at it from a side view, what I'm looking for is the center of pressure and the center of gravity. So this center of gravity is right there, and it's at a CG position of 29.72 inches from the tip of the nose cone. On this one right here, which is the new version, the CG moved back just a little bit to 30.75 inches. Now I'm asking, why did that move back a little bit? So something changed, because basically we just took the rings and we took them from the outside of the rocket and we just slid them inwards. We didn't change their front back position. So that tells me that something changed a little bit, and I don't know what it is. Because that would probably take a little bit more looking at. See if something changed on my fins. And they're also G10 fiberglass. The dimensions didn't change. So why did that CG position change? I don't know. But let me look at the CP location. So this CP is at 42.49 inches, and the other version, the old version, is 43. So what happened here was the CP actually moved rearward in the new position, and that doesn't make any sense either. Well, it could make sense because I wouldn't have expected it to. I expect it to move forward. So this is the new version. This is the old version. The old version is at 43. This one is at 42. Oh, so it did move forward. So that is correct. That is correct. Because the rings were out here and we moved them inwards, they're less effective at producing lift and drag, or at least lift. So you do expect them to move forward a little bit, the center of pressure location. But I did not expect the center of gravity to change. That should have stayed the same. So something changed here, but it's not that big of a deal. It's going to be what it is. But that center pressure is a big deal, so that's why I was looking at it. As long as the center of gravity is in front of the center of pressure, we're going to be okay. This is the new version, and we're going to be okay, because even when you put a motor back here, I don't think the center of gravity is going to go too far back. Let me see what motors he was using. He's got a I-200, so let's load that motor. So I'm going to select the simulation and then just hit load engines, and it loaded the engine, and the CG did move back to 32 inches, but it's still in front of the center of pressure, so we're okay. So that is how to do through the wall fins on a ringtail rocket, or tube fin rocket. I keep calling it ringtail. Okay. Really good question. Oh, we got a lot of people talking here in the chat. Carlos K says, using RockSim, will my Apogee Avian go higher with a C engine on a hot day or a cool one? And where can I examine the effect of air temperature? Oh, that's an easy one, Terry. And the answer should be yes. It should affect your rocket. let me save that design. Let me open up a different, Avion maybe, before we take our next question from that came in. RockSim Designs. I'll just open up any old design, it doesn't really matter. Estes Alpha. We'll open up that, because you can do the same thing here. Okay, so we're going to load a C engine. So here's a C67 that's in the flight simulations already, and so I'm going to just go load engines. If you're brand new to RockSim and you don't know how to load an engine, you go up to this button right here, and this is prepare for launch, and it brings up this screen, and then the first thing you do is choose your engine. And I want to show all engines, and the diameter only matches the motor mount diameter. And then I want to go to an Estes C6, and we'll put in a C67. Click OK. Okay, so now what you do, Carlos, is you wanted to change the effect of temperature, and that will be under the launch conditions. So here's your launch conditions. And then if you come down here to temperature, here's the current temperature that it's set at. So note that, that's 59 degrees, and do a launch. Okay, and if I change nothing else, and if I just change the temperature, so I go to launch conditions again, and let's make it 99 or 95 degrees, make it a really hot day. Hit tab, and then do a launch again. So the only thing we changed was temperature. So here, under the old temperature, it was 1,372 feet. Under the hotter temperature, 1,409 feet. So as the temperature goes up, the altitude goes up. And why is that? Because hot air is less dense. Because it's less dense, it's going to have less drag. You know, instead of flying through thick soup, you're flying through clean, clear air. So, you know, as the temperature comes down, the density increases of the air because the air particles get closer together. And so you're trying to push your rocket through particles of air that are closer together, and so you get higher drag. And so that's why you'll see that temperature difference. So just change the temperature. See, that was a really easy one to do. Okay, so let's go to our next question. We had one from Fatbank, and he said he was asking why the Apogee 170 RockSim file shows the second stage graphics are upside down. So let me open up an Apogee High. Open. Let me go back to my RockSim designs. You can download this from the Apogee website, but what did he say? Apogee 170? Apogee 170. Okay, so here's the Apogee 170. Save my changes? No, I don't save those changes. Okay, so here in my design, the images look correct. But if you open the file and they're not correct, so if this one, you know, say the A was on this side and these bands of color were on the bottom, how do you flip those? And that's really easy to do as well. Go to the Rocket Design Components tab, find the tube where the decals are, so it's this tube right here, and it will highlight it right here, and then we're just going to open that up and edit that. Okay, so here's the decals, and then just go to the texture tab, because the textures are what we call decals. And then there's these position sliders that you can move around, and one of them, there's some flips. There's a flip around the R axis and flip around the S axis. If you just start clicking on things, you're not going to hurt the rocket, so don't be afraid to click on things. Just check things. I'm going to uncheck that one and see what happens. Oh, and that did it. That flipped it. So that flipped around the R axis. And if I check it again, it'll flip back. And if I flip it around the S axis, yeah, so basically it took the whole thing and when it took it like this. So we don't want to flip it around the S axis. We want to flip it around the R axis. But you can also change the position by moving these slider bars. You know, if I grab this one right here and start sliding it, you can see it's sliding it around the R axis. And if I slide it around the S axis, I'm just sliding it around and seeing how it looks. So on this one, it kind of slid it forward. You can see as I move the slider bar, it's changing the position. So don't be afraid to move those decals around until you get them positioned like you want them. So I'm going to cancel that. So that was a good question, Fat Bank. Okay. Terry Wheelock says, he's talking about the crash that I had. If it is a critical flight item, yes, it will crash in the simulation. That's funny. John Papp. John Papp says, okay, I got it. I want to, oh, he had one up above. Is there a way for RockSim to alert me that I may be missing in my design, to what I may be missing in my design? And the answer, John, is no. Some things it will tell you, alert you. Like if you make a fin and you don't select the material, it's going to alert you because it needs to know that material. But if you're missing like a centering ring and you don't put it into your rocket, it won't alert you for that. So this is where you have to have a little bit of rocketry experience. Let me change screens here. So here I have a see-through rocket called the Vapor. And it allows you to look inside the rocket and see the different parts. So, and it labels them. So we got nose cone and nose cone shoulder gear at the bottom. You can see the parachute on the inside. You can see the shock cord. So you need to know the names of your parts, and then in general what you're going to need for a rocket. So if you've built a rocket before, you kind of have a general idea of what parts are in a kit. So when you're designing a rocket yourself, you might take an instruction sheet for a rocket that's somewhat similar. So, and then look at the parts list on that instruction sheet. So let me go to the Apogee website and let's go to an Avion. So go here to the search bar and type in Avion, and it will bring up a list of things to select from. So here's an Avion kit, and this one doesn't have an instruction sheet. Let's go to Maker's Dozen. So here's the Maker's Dozen rocket. I know this one has an instruction sheet because I was just looking at it the other day. So if you scroll down on the page, it says download the assembly instructions. So if I click on that, it's going to download them, and then it's going to give you a parts list of everything that's in one of these types of rocket. Oh, you're not seeing it. So let me do that again. So I went to the search bar on the Apogee website and I type in Maker's Dozen, or just Makers because it's finding it, and then click on it. It brings me to the Maker's Dozen parts, or the kit page. And then if I scroll down under the related documentation, it says download the assembly instructions right here. And if I click on that, it downloads them. And so now I'm seeing the instruction sheet. And you can see your instructions, and it'll kind of guide you through the assembly of your rocket. But what you want to do, if you're unsure if you got all the parts in your rocket, look at the parts list right here and just say, hey, do I have one of these? But you got to know what this is. Like this right here is a motor mount tube. This is the body. This is the, can't get the one in the middle, the 96 part. That one right there in the middle. That's the airframe tube. I got some centering rings. That's going to be used as an engine block. I got launch lugs. Usually when I make a design in RockSim, I always forget the launch lugs. I forget to put them on. So it does happen to experts as well, John, that we forget to add parts to. But as you come across a design that's missing a part, just go ahead and add it. Make your design complete. So that's what I would suggest. Just use a previous kit, something that's somewhat similar to what you're designing. Just go through the parts list and say, hey, do I have one of those in my design? And then, where are they located? I got my engine hook. I got an engine block here in front of the engine hook. I got some centering rings, putting the fins on, whatever. So that's what I would suggest you do for, do you have all the parts in your rocket? And John Papp says things like baffles versus wadding and reinforcement tubing, etc. A mastered parts list sounds like a great idea. Again, John, what you do is on the Apogee website, we got so many kits. If you go to the shopping and just go down here to sortable rocket list right here, click on that, and that's going to give you a list of all the rockets that we sell, and it'll show a little picture. So the first thing I would do is designing a rocket and you're unsure, is just kind of scroll down through the list and find something that sort of looks like what you got in your mind for your design. Then go to the kit page, download the instructions, and it will have a parts list. And then from the parts list, you can look at it. So he's talking about a kit with an ejection baffle in it. So I'm thinking in the back of my mind, what kit has an ejection baffle in it? That's a little bit harder because it's not obvious by looking at it if it has an ejection baffle in it. So our ejection baffles. How about the what's the name of that cluster kit? I know we got a cluster kit. We got so many kits, I just forget all the names. So now I'm looking for a cluster kit, because I know one of our cluster kits has a engine block in it, or a engine baffle. Gliders, clusters. And I'm looking for the Apogee. Oh, here it is, flamethrower. So I believe the flamethrower does have a baffle in it. Let me just check it here. Yeah. No. It does not have a baffle in it. But I'm sure you know a kit that has a baffle in it. Yeah, I can't remember. I know we have kits with ejection baffles on it, but that's what I would do. If you probably, in the top of your head, you probably know of a kit that has a baffle in it. So look for kit instructions. Okay, John says, I really want to get my custom nose cone into RockSim, but I have yet to figure out how to do that. Yes, so that was one of my next questions. So John sent his custom nose cone that he wants to put into RockSim, and he sent a drawing of it. And John, this is so awesome. I was talking with Martin today. Martin is our designer, and we were talking about the process of designing rockets. And step one, even before you go into RockSim, step number one is get out a piece of paper and just doodle on the paper and draw what you got in your mind, because that way you can convey the information to other people. And so, John, I applaud you for doing that. So he's got his custom nose cone and he wants to put it into RockSim. So we'll take this one next. So the trick to doing this, John, is don't think of this as one piece. We're going to break it up into parts. And we do this in engineering all the time. It's kind of like a rocket launch. We break it into parts. We have the ascent phase and then the descent phase. And we're going to perform 2 simulations on them and then just add them together. So we're going to do the same thing on this nose cone. We're going to break it up and then add it all back together. So we're going to break it up wherever I see a joint line, like right here, there'll be one part. So that'll be one part from there to the tip. And then we got a straight section, and then we got another transition section, and then we got another tube section down there. So that's how we're going to design this. And so I'll start a new design right here. And so I'll just click on the file new. Do I want to save that one? No, I'm not going to save that one. So we're going to start from scratch. So first we're going to add this part, and that one is shaped like a nose cone. So that's where we're going to start. And he's got this thing at, I don't know how big in diameter that is. That might be like 4 inches. So we'll call that 4 inches. So when you first start a design, it always looks in the database. And so I'm going to cancel out of that. And so I'm going to a blank screen. And so now we need to select what shape this is. And it's not conical, because if it was conical, it would have a tip on it, or like a point. So my other choices are ogive. Ogive it could have a point on it. Parabolic, elliptical. I think that might be closest to parabolic. We'll try parabolic, and if it doesn't match the shape that we want, we'll select one of these other ones and try to get it as close as possible. Are you going to get it exactly perfect? Maybe not, but as long as it's close enough, in engineering terms, it's good enough. So we're going to select parabolic. For the material, I'll make it out of plastic, because I assume he might be 3D printing this. So I'm just going to choose a plastic like polystyrene. And I don't know what the length is. That's like 12 inches, so maybe like 3 or 4 inches long. Diameter 2 inches. You can see now it drew the shape of the nose cone there, and this is solid. We'll make it hollow. Give it a wall thickness, 0.06. That's kind of like my default. 0.06 is like that. Like you can see that right there. But I don't like the shape. It needs to be more rounded near the tip. So I'm going to choose a different shape. Elliptical. I'm comparing this shape to this shape. It's better. Power series. When we get to the power series, then we have to start doing some tweaking here. Maybe this is too long. Maybe make it 3 inches. That's not terrible. Let's see if we can get there with a parabolic series, or the parabolic series is always going to have a tip on it, a pointy tip. The Sears hack. Ooh, that's not bad either. It's a little bit pointy there, but other than that, I think I could live with that. I'm just changing the shape control, just moving things around. Let's change the color. Color is pink. I'll leave it that way. All right, so now we got the front part of the nose cone. Now we're going to do the straight section. So I'm going to come back here and straight things. What from this list can we say that it's nice and straight? Well, a tube. So we'll select tube. And again, it looks in the database. So I'm going to cancel out of the database. And remember, we said the nose cone was 2 inches in diameter. So our outside diameter is 2 inches. And you can see it drew a blue line. Inside diameter, we'll make it 1. Come on, I need 1.84. I'm just guessing here. And then the length, it looks to be just a little bit longer than the nose cone. So our nose cone was 3 inches, so we'll make it 3.5 inches long. And we have that. And the color, we can make it the same color. I forget what the color was. I think it was red. Let's see what color. Nope, it was magenta. This color? Yeah, it's closer. It's more purpley. So if I want more purple, I'll move it this way. Okay, that's close enough. And then the 2D color, I think it was yellow. We'll make it orange. Okay, so now we've got that plus that. Now we need this little transition right here. So we're going to add that transition. So here's the transition button. So I'm going to click on that. Again, it looks in the database. We're going to cancel out of the database because this is all custom. I need to select the material. This is going to be, again, the same material. I'm assuming he's 3D printing it. And the wall thickness is the same as the wall thickness on the nose cone. So let's set the length first. So that length, let's call it like 0.6 inches. And then the front diameter, we know the front diameter has to be 2 inches because we're trying to match this shape over here. 2 inches. And then the rear diameter, he has here we have 1.445, so that's 2.90 is the rear diameter. 2.90. Oops. I mean the front diameter is 4 inches. No. I screwed up. I should have set this diameter here. I was thinking radius. Because down here at the bottom, which you can't see, he's got a diameter here, or a radius of 1.445. So I was thinking that this was 2 inches, but that can't be right. It's got to be 4 inches. So I could easily go back and make these diameters 4 inches, but I think I'll just make this one 2 inches. So we're just showing the process. 2 inches there. And then this one, instead of 1.45, so we'll make that 1.45, 445. Okay, so here's that. Let me look at it in 2D. So it's a really light color green. That's really hard to see. So let me darken that up so you can see it. I'll make it a dark green color. And in 3D, we'll make it, again, that purplish color. Let's go back to the General tab. Let me give my image over here so you can see what I'm looking at. Okay, so you can see what we're trying to match. So this is getting closer, but you can see it's got a little curve to it. We can adjust that shape again with the shape control. So again, we'll try. Ooh, that one looked really good. That's ogive. See, ogive, but it's got a point here at the end. Parabolic is also going to be the same. Elliptical. Ooh, that looks pretty good too. Power series. When we do power series, we start getting the shape control. I don't like that as much. Parabolic series. Again, we're just sliding the slider bar around. That doesn't change anything. Sears hack. Sears hack. Definitely don't like that one. So I think I liked the parabolic. No, it wasn't parabolic. It was elliptical. Okay, so that matches this curve right here. And now we just need that portion right there. Click OK. Let's look at it in 3D. So we're getting close. We just need one more straight section on there. So again, we'll just use the body tube. Cancel out of the database. Outside diameter 1.445, 1.445. Inside diameter, we got to set that. So let me give him a calculator here. So 1.445. What I'm going to do is I want the wall thickness to be 0.06 to match the wall thickness of everything else. So 0.06 on each side is 0.12. So minus 0.12 equals 1.325. So that's going to be our inside diameter, 1.325. And now we just need to set the length. And on this one, he has it at 4 inches. So we're doing a half scale version here. So that is, let's just checking the colors. So that's the nose cone that he wanted to make. And so from here on out, now it's just adding the rest of the part of the rocket. So all these three components together is what he called his nose cone that he's 3D printing. So that would be how you create a single part that's a collection of individual parts. Now, what you could do also is group all these together. Remember, we said that we can group parts together, like a sustainer is a group of parts, a pod is a group of parts. There's another group of parts called the subassembly. And so you can attach all these parts to a subassembly and then save the subassembly, and you can use it in multiple designs. But that's a lot of steps. So I would, if it was me and I wanted to use this nose cone on multiple rockets, I would just save it as my nose cone starter, because it's the start of my next design. And I'm going to throw it on the desktop. So then I could add parts to it and call it up and add parts to it. And that leaves the original one alone. Carlos K. says, given the upcoming moon mission excitement, would you consider in a new RockSim version a way that students could launch their models on the moon? We have thought about that, Carlos. You know, once you do the moon, then you want to do the Mars, and then you want to do Venus, and then you want to do Saturn. And so basically you have to change gravity. And it's doable. It's just it's doable, and it's not hard. It's just we would have to weigh all the other things that we want to put into RockSim versus having the ability to launch from the moon or from Mars, other celestial bodies. So we haven't ruled it out, but it's not something that's in the immediate horizon because I'm working on other things for what we want RockSim to do. But very good question. So let's go to, I had a question. Okay, so this design, his question, he's a Okay, so he's got a design. His question was, the top half of the rocket weighs 250 grams. The bottom half weighs 150 grams minus the motor. We're trying to determine the parachute size and dimensions for each half. I believe I can use the descent mass calculation that is listed on the parachute, and that seems to be automatically generated. I wanted to know if there's a way to firmly change the descent mass calculation on both parachutes so that we can get an accurate reading of the descent rate of the rocket. And then he sent me his design, and I told him I would talk about it, so let me open up his design. So here's his design. And if you're familiar with like the TARC program, this looks very eerily similar to a TARC rocket. Because if you look at the size, it's 2.2 inches in diameter. And if I look at some of the parts in it, he's got an egg right here. He's got an altimeter right there. So this is kind of a TARC rocket, and that led me to the question. He's got two parachutes. He's got this parachute right here, and he's got a parachute right here. But they're in the same rocket. So usually when you think two parachutes, you're thinking dual deployment. But if I think of two parachutes in the context of the TARC competition for this year, your rocket has to separate into two parts, and each part comes down separately. So the way that this is set up just like dual deployment. So if I went to the flight events tab, I will see both of my parachutes, and they're both in the same location, although you can't tell it from here. So this is set up like a dual deployment rocket and not like a TARC rocket where we want them to separate. So the trick here, Michael, is we got to do a little trick. Remember what I said before, we're going to take the, when you have a situation and you can't make it work as one giant component like that nose cone, we break it up into parts. Or in a simulation, we have the upward part and then the descent part. So here we're going to create a rocket. We're going to break the rocket into two parts, and we're going to design them and recombine them in a way to make it work, the simulation work. And the way we're going to do this is we want, the only way that RockSim can track two parts that are coming down separately is if it's either pods or is this a staged rocket. If you look at a two-stage rocket, you can see the booster stage falling separate from the upper stage. So what we're going to do in this situation, we're going to create that same situation. We're going to turn this single stage rocket into a two-stage rocket. And it's pretty easy to do because you already got all the components in there. We just have to separate what we think is the bottom part from the top part. So first, what I want to do is turn this rocket into a two-stage design. So to do that, go to the Rocket Design Attributes tab, and then come down here to Number of Stages, and we're going to say this is a two-stage rocket. And I'm going to call it Michael, M-I-C-H-A-E-L, Michael Rocket. So, and I'm going to save it on my desktop. So file, save as, so I don't override his original design. Okay, so it's saved. Now I have to decide by looking at these parts where it's going to separate. And my guess is it's going to separate right here at the front of the base, at the front of the bottom body tube. So everything that's attached to here is going to be in the bottom stage of the rocket. Everything attached here is going to be in the top stage. So if I look at it here, so here's the bottom stage, and everything that's attached to that, I want to put in the booster stage. So it's really easy to do. We're going to copy this body tube. So when it copies the body tube, it copies everything that's attached to it. So I'm going to do a copy. So again, right click on the body tube, do a copy, and then I'm going to come down here to booster stage and I'm going to paste it right there. Come on. Go to file, paste. There we go. So it pasted it right there. In fact, did it move it? No, there's my body tube. I got two body tubes here. So now I'm going to take this first body tube, I'm going to delete it. Say delete, yes. So why wasn't I seeing that bottom part? And the reason is because it's set to only view the top stage. So if I turn it back to a two-stage rocket, now I'm seeing the bottom stage. And really, so that's the first part of the trick, is just rearranging the parts. So now I have a booster stage and a sustainer stage. And now I got to set up the simulation to run it as a two-stage rocket. But his question was, now the mass, can we separate the mass? So let's look at the mass of the sustainer stage. So let me turn off the booster stage. And we can see the mass is 441 grams. And so that's the mass that's going to come down with this parachute. And if I turn it back to a two-stage rocket, now I got a new mass. The mass should have been smaller. Why is my mass, does he got mass override turned on? No. Because this is a two-stage rocket, the mass should have changed. Selected stage mass, 4.41. Oh, okay, I was looking at the wrong number. I was looking at this number. This is the mass of the entire rocket. This is the selected stage mass of just the upper stage. So 304.241 grams. So that means that if you take 441, I can figure out the bottom stage mass, getting out a calculator. 441.976 minus 304.241. So my bottom part of the rocket weighs 137 grams. So hopefully, Michael, that's what you needed to know. So now if you need to adjust the mass of the upper stage versus bottom stage, you can start doing that by doing a mass override or adding a mass object or whatever into that particular part of the rocket. But now you need to run the simulation. So that's the second part of the little trick. So now on a two-stage rocket, when you go to prepare for launch, it says in order to run simulations, at least one body tube in each stage needs to be designated as a motor mount tube. So what it's asking me is I've got a motor mount in the bottom stage, but I don't have one in the top stage. I need to put one there, is what RockSim is telling me with this message. So we're going to say, yes, let's designate something in this top stage as a motor mount. And now I don't know which one is which. So there's multiple tubes here. We have this tube inside, because when he designed this rocket, he didn't change the names of the parts in the parts tree. I can't tell what this body tube is versus this body tube. I got a tube coupler here. So actually I got two tubes. I can make a motor mount. I'm going to call this one the main body tube. So I'm going to edit that one, main body tube. And I'll edit the upper one, and we'll call this one, he's got this one as the altimeter tube. Click OK. So now when I do that and I get that message, I got to select one of them as the motor mount tube. It selected the altimeter tube as the motor mount tube. And it's okay, because what we're going to do here to run this simulation is we're going to put in a fake rocket motor so that we can run it as a two-stage rocket. Again, this is engineering trickery, but it will work. So in the bottom stage, let me cancel out of this. Let me take a look at his previous flight simulations. He's using like an F-24. So when I load an engine into the body tube, this is the booster stage. I'm going to choose an F-24. Let me engine code. Let me sort by that. So here's an F-24, and what delay did he have? F7 second delay. So I'll choose a 7-second delay and click OK. All right. And if we go to the flight events, so now we have a parachute in the booster and a parachute in the sustainer. So at the booster parachute, I want to deploy that one at stage separation. So what determines stage separation? So if you're familiar with a two-stage rocket, we know that stage separation occurs when the ejection charge of the booster motor separates the rocket. Now, most people think that a booster motor that ends with a 0, like a D12-0, doesn't have an ejection charge. I, on the other hand, says it does, because you do anything that throws flame forward, I call an ejection charge. So there's flame going forward that will separate these two stages. So in a 7-second delay, stage separation is going to occur 7 seconds after motor burnout. So we're going to deploy this parachute as soon as separation occurs. And then the upper parachute, I can look at my events right here. I can deploy it at an altitude, an apogee, after a time after apogee, a time after ignition, or maximum ejection delay. But we don't have an ejection charge in the upper stage. So if we go back here, we don't have a motor in here, so there's no ejection charge. So right now, if we ran the simulation, that parachute in the upper stage is not going to come out, but we need it to come out. So this is where I said we're going to put in a fake rocket motor. And so in RockSim, if I go to choose engine, I need to choose an engine that has no thrust. It's just the sole purpose of it is to do this specific trick. And I think we put in a special motor in the RockSim database that will allow us to do that. And there we go. If I sort the engines, you'll see there's a motor called fake, and this is my fake motor. And if I look at it, it has just a fart of total impulse, because I had to create a thrust curve for it, and it's got to be greater than 0, but it doesn't have to be much greater than 0. And this is 0.000 seconds of Newton seconds of total impulse. So it's hardly anything. And I've got one here that's even smaller, so I could use the Apogee Dart or the fake one. I think you'll find one of these in your database. So just show. You can do a diameter filter to show all engines, or just to show the ones that are of the motor mount or smaller, because look at the diameter of this. It's 6 millimeters. So this is like the smallest diameter motor in the database anyway. So I'm going to select that one, and I'm going to say that it does have an ejection charge. So I'm going to give it an ejection charge, but I'm going to do it as a custom. So I'm going to set the ejection charge to happen at 0 seconds after motor burnout. And when is motor burnout? If I look at the burn time, it's 0.06 seconds. So it's kind of like right there. So in real life, the rocket takes off, it ejects, everything happens all in engineering terms about the same time. So that's how we can get away with this. So I'm going to say OK. And so if you look here on this upper stage, there's my new fake rocket motor, and I call this a dart motor. And it has a 0-second ejection delay. And now if I go to my flight events, I can set the deployment at maximum ejection delay. So as soon as the motor burns out, it's going to fire that motor. But since our burnout time is like instantaneous, as soon as this one separates, it's going to also kick out the upper stage parachute. So let's launch this rocket. I'm just kind of looking at my flight here. I'm going to give it a little bit of an angle so that we can actually see something here. And then let's look at the flight profile and just confirm that everything is happening. So down here under my face is the rocket sitting on the pad. And when we launch it, the rocket takes off, it straightens out. You can see it's a two-stage rocket, and the bottom stage is the pink one, and the upper stage one is the blue one. And right there is when stage separation happened. This little smoke is the ignition of the upper stage, but they both separated at the same time. You can see it happened almost instantaneously. And now you can see them falling. This green line is the upper part, and this red line is the booster stage. You can't see the parachute on this in RockSim, but it is falling slow enough so you know that something happened. And if you really want to see the parachute, what we'll do is we'll upload this design into the launch visualizer. So let me save this design. So it's saved. And let me open up the launch visualizer. So I need a new window. The launch visualizer is at rocksim.com, and anybody can use it, but you need a RockSim file. So I created the RockSim file, I saved it, it's on my desktop. Now I need to upload it into the cloud so that I can see the simulation. So to do that, go to login. And if you don't have an account, make an account. I already have one, so I'm signing in. And once you're signed in, we're going to upload our new design. So I'm going to click Upload, go to Browse. Okay, and I put it on my desktop. There's the Michael rocket. Open that. We're going to upload it, and it's uploading it to the website, and it will show the rocket design here, and it's not showing my fins. It's only showing my upper stage, and this is a two-stage rocket. See, here's that last one that we just did. So when I look at it, why am I not seeing the bottom stage of this two-stage rocket? Let me go here to select motor. I'm showing the two stages. My programmer, we just uploaded a new version, and apparently it's got a bug in it. So I can't see it there, but I can do it in RockSim Pro. Let me do it in RockSim Pro. So file open. RockSim Pro is very much like the launch visualizer as far as the simulations go, but it's not in the cloud. It's on your personal computer. So the desktop. I just want to show that both parachutes are coming out. But in RockSim Pro, we got to set up the simulation a little bit different. So here's the rocket again. Here's my flight simulations. I want to go down to that last one. I want to load engines. So it loaded the engines. Let's check the flight events. So in RockSim Pro, under flight events, I have to have in RockSim Pro, you have to tell it when to stage. And that's why I have a staging event right here. And then I have my 2 parachutes. And in RockSim Pro, I can tell them where they're located. This one is located in the bottom stage because it's labeled number 2, and this one is in the upper stage. Okay, so the first one, staging is going to occur at maximum ejection delay. So that's at the 7 seconds, because remember we have the 7 seconds here. And then our upper stage, remember we set it at maximum ejection delay, and that's right. And the parachute in the bottom, we also want to set that one to maximum ejection delay, but in RockSim Pro, because staging is different, we have to set it up a little bit different. So this time we're going to time relative to stage separation. So we want it to be any time greater than 0 seconds after stage separation. So as soon as 7 seconds happens, stage separation is going to occur. And at that time, we want the parachute and the booster to come out. So let's see what the starting state is. We got a little launch angle there. Let's see the flight profile. Let's see what this looks like. This one should work. Crossing my fingers. I think my camera froze. But the screen is still going. So we'll just continue to go here. We're going really long today, but we had so many questions. Okay, so here is the rocket sitting on the pad. It looks like a single rocket. And we're going to launch it. The rocket takes off. It's going upwards. You see the ground in the background moving. It's getting to Apogee. We hit Apogee. There we go. Let's pause it right there. So if we zoom in on this, I lost my rocket when I zoomed in. Okay, let's zoom in. It doesn't look like there's anything there, but there's got to be a rocket there somewhere. Show me the rocket. Okay, so here, let me zoom out just a little bit. So here's the upper stage. The parachute came out. Here's the booster stage. And, oh boy, it's navigating around in 3D dimensions is really tricky. But you can see my booster stage right there. You can see the fins on it. If all your parts are the same color, it's hard to distinguish things. So not only change the names of your parts, change the colors too, because that will really help identify things. You know, if this one had a different color parachute than the upper stage, I could more easily tell them apart. If the fins were a different color than the rest of the tube, it would be easier to see as well. All right, there was one question that I did not get to, and that had to do with how to troubleshoot a design, but we've gone like 20 minutes, way too long today. But there was so many good questions, and I didn't even get to the chat, and I apologize for that. Oh, we have somebody else from Australia here today. Cool. Hey, Kangi. John Papp, trying to design 3 versions of what is really a finless rocket. First with fins to keep it simple, then a tube launch with flip can fins, and then a launch pad with thrust vector control. John is working on a really hard project there. Maybe we'll talk about that one next week because I don't have time today. It's a really good question, John. Terry Wheelock says, hey, getting Tim to design your Tark rocket is cheating. Well, it's not cheating if I don't send him the design file, but I want you to see the process. And if the process did not make sense to you, we did do a video on this on the Apogee website. And that video, if you go to How To and Guides, come down here to Software, and then go over here to RockSim Video Tutorials, and then here's video tutorial number 3, setting up a simulation where the nose cone returns separate from the fin portion of your rocket. And it's a shorter video, it's only 6 minutes long, but if what I showed you here live didn't make any sense, watch that video, and that will get you going. Let me see if my video camera froze. So you don't get to see me waving my hands around doing crazy things. But we will be back again next week. Next week is December 9 and 7 is 16. December 16 at 2 p.m. Mountain Time Zone in the United States. That's 4 p.m. on the East Coast, or 10 p.m. in Amsterdam, because sometimes we get one of our regulars is in Amsterdam or in the Netherlands, and for him it's like really late at night, and I appreciate it. And it must be like really early in the morning in Australia. So thank you for coming. I appreciate it. We will be back next week. So in 5, 4, 3, 2, 1, go out and launch something.